So today we should continue the conversation on credential rotation. So I went back and looked at some of the topics we've been discussing about, and the first thing I found was the KMS based credential rotation is only for encryption keys and not for access keys. So that wouldn't apply to creation of or rotation of access keys like we originally thought. The second thing is in terms of AWS alone, and I know that there are equivalents in GCP and Azure, but I haven't had the time to explore that in detail. But in AWS, we have this concept of simple secure token service (STS). Vianney brought it up last week or last meeting. What it is you create a token with a predefined expiry and a small set of or a very constrained access on it, or access provision for it or given to it, and that token can be used to assume the role of a certain user and make requests on behalf of that user. So I believe as of right now, that seems like the best approach in order to create short-lived credentials, um, because um, because by default the access keys and secret keys do not have an expiry on them. So Vianney, um, that
Yes.
sounds so. So can you talk about STS more? You were proposing it last week. Did you have anything else to add?
No, so I can explain for those who don't know. So you first you need to prove you are the person you claim to be,
Mm-hmm.
and you do that. Sorry, typically with for instance OIDC. So you come with an identity, your an email address typically,
Mm-hmm.
and when so typically when IAM, the Amazon service validates your OIDC token in this
Mm-hmm.
case. It says, okay, it's you, and I give you temporary credential, like formed by an access key, secret key, and a token,
Mm-hmm.
which is bound to a policy.
Is bound to
Uh,
what?
it's bound to a policy which
Mm-hmm.
defines the actions you can do on the service. So
Mm-hmm.
typically, for instance, you can write in this bucket, for instance,
Are
and
they
for
revocable?
sorry,
Are they revocable?
that's a very good question.
Who is supposed to possess this token?
This would go to the workload.
So the user. So once you're authenticated, and
How does the user obtain the token?
um, typically by calling assume role.
By calling what?
So it's a specific opcode in IAM. It's called assume role, and you simply call assume role, and you are return temporary credentials. So basically, the triplet access key, secret key, and STS token, just like you would have an access key or a secret
In
key.
what framework? I'm just confused here.
What do you mean by framework?
If I'm a Kubernetes user and I create a pod, where's my token come from?
So the driver creates the token and provides the token to the workload using the normal mechanism that we've been talking about throughout.
Yeah, so
Okay.
instead of returning what we call static access keys, so access key, secret key, it returns a triplet access key, secret key token, but it's exactly the same.
Okay.
And the applications, they know how to consume it as well. Just you just have a new parameter, which is a token, right?
And this works across AWS, GCS, Azure, all the providers
Yeah,
have identical functionality.
yeah, and also other object storage vendors have it.
Okay, so this is somehow like an additional de facto standard
I
that
wouldn't.
has.
So this is purely advertised as temporary credentials. The advertised use for this is to give you an upload link, for instance, that's active for a day or active for a week.
No, I mean, I get the concept. Like there is an API that, using a special credential lets you do stuff. The question is, how standard is it, and do we want to depend on it, right?
Right.
Because if anybody doesn't implement it, then you lose out on portability, and we'd have to figure out, like, is this some
All three have
extension?
it.
Huh?
I've done the research. All three have it. I can actually show you um, what it looks like. So I was just looking up if STS can be revoked. It is possible, so that's good. STS is the temporary credentials. Whereas yeah, so in IAM we know it's STS. On GCP it's Security Token Service. On Azure, Secure Token Service. Yeah, they also have it. No, this is just.
I guess as I think about this, so I mean, I see a few problems. One is, while the big three vendors may have it and a handful of smaller vendors may have it, I still doubt that it's universally
Everyone has it.
supported.
True.
And so, like, we would have to make it optional somehow, right?
So the
Or freeze out
question
certain implementations. And
is do we want to support it in COSI?
well, but the other problem is a bigger problem in my mind, which is this seems to just push the problem up a level, right? If what we're giving you is a token that you can use to obtain tokens, like, that's all well and good. You can rotate your own token, but, like, the whole reason you rotate the token is out of fear that your token got stolen. And we're giving you the token that you use to make the token. So what if someone steals that token? Now they can also make tokens for themselves, and, like, you haven't solved any problems, right? You've just said, like, here's the secret you use for making secrets. And
Oh, you don't use it to make secrets. So that's the other thing. It's a session key. You just use it.
right, but you know what I mean? Like, the point of key rotation is the fear that keys will leak and that bad people will obtain them and then hack your data. And so by rotating them, you limit the window during which anyone can do this. But, like,
not really. You, for instance, you can say that, for instance, your driver has got a specific OIDC role within Kubernetes, and so typically the driver is is authenticated and has the right to generate temporary credentials for users, for instance, or for bucket access requests.
you're saying
You
using your Kubernetes service account, you can obtain the right to do these things.
You could do that because you could map the driver service account to an OIDC token, and then so you don't have to basically have an initial.
Yeah, that's what I was getting to. So last week when we were kind of finishing up the meeting, one of the discussions, I think one of the things that Ben brought up was, for the simple case of provisioning access keys and secret keys, we don't do rotation because it just makes the life cycle. It doesn't really add much value, like just like the case you was talking about right now. But where we do credential rotation or where we have more advanced access control is when we start doing the IAM style access. IAM style access is where a service account, a Kubernetes service account, is associated with the cloud service account, and based on that cloud service account, you'll or on that cloud service account, you will set the type of access that's allowed for that service account, and the Kubernetes service account will be given to the pod. And so the pod will be able to use that and make calls on behalf of the cloud service account, and that's where we can do more. I mean, that's the IAM style of access that happens in cloud providers, where um, based
But
on
is
where
that
it's been called.
strictly
Mhm.
S3, or is that talking some proprietary
No, it's it's
API?
it's it's not. It's where it gets the access from. Um, So if you're in an Amazon instance, if you're in a AWS instance, um, if the instance has permissions to talk to a bucket without needing any credentials, you'll be able to just talk to that, get
Right, but
into.
what will actually happen inside the pod? So the pod has access to a token that it can use to get the bucket, but like in order to assign an HTTPS header, it still needs an access key and a secret at
Yeah.
some point. So like, is there just a process to take your your access token and go to the S3 service and say, give me a access key and secret that I can use to perform my signature?
let's
And that's
let's
just
yeah, let's take a look right now. um, so um, I'm thinking about where the code is. I think it is here. No, here. So no, not here. It's under credential. Okay, so I think here. So this is a drop in replacement for S3 CLI. I'm just aware of how this works. So I'm taking a look here. So there is one type of access where IAM AWS access, where just depending on where you. Okay, yeah. So what it does is it talks to the link local IP address, which is the metadata service that's available on, again, all VMs. Um, and it uses that to get an STS token, and then uses that to get the credentials.
okay. So this is basically what we were already planning on doing with IAM style authentication.
Yeah.
Okay, we just need to. I guess I'm not familiar enough with what it looks like when you do the BAR and the BA for this type of access, because we don't have any data to convey, right? It's just basically we just need to express that trust exists.
Right. So
or
here's
something.
what is needed. So in order to make the call to the backend, so it needs these are the things that it needs. Um, either a web identity token file, which is the file that contains the STS token. Along with that, it needs the ARN is Amazon resource number. It needs the role for that, or the ARN for the role. So in terms of BAR and BA, we create the role, and we'll have a name. We'll have the ARN for the role that will need to be passed through.
But this
And
doesn't look portable.
sorry,
This doesn't look portable.
we'll have to look at what the equivalent is in GCS and all that. It doesn't look portable, I agree.
But I mean, like if I'm just trying to use S3, like then this is never going to work, right? Like I would have to have a different protocol that says I actually want to speak like Amazon proprietary S3 or GCS or Azure, some proprietary protocol to take advantage of this stuff.
So
But how
what
is it
Cozy
more
needs to do,
proprietary than S3 is? That
this is all for S3. So what Cozy needs to do is just have a mechanism to pass just one of these types of credentials all the way to the pod. There is a concept of, so what I was talking about here was web identity token file. There is a concept of a relative URI, container credentials relative URI, container credentials full URI. I think this is what we should be looking at. I need to go figure out what this is a little bit more. Um, So what I believe container credentials is the service account. Yeah, I need to look into this a little bit more. To be honest, I haven't gone into this enough at this point.
I mean, I'm sure that there's a lot of very cool and fancy things we can do once you're willing to say like I'm going to tie myself to Amazon or tie myself to Google or Azure, or I want to pick one and just be compatible with that one. But if I say I want to be portable, where I can just take this workload and dump it on any old cloud anywhere, and if they claim S3 support, it's going to work. Like I want to be very careful about what is above that line and below that line, and none of this looks like it's portable.
True. We can't
So
reasonably expect every vendor that's there right now and in the future to support this.
yeah.
Can this be optional though? If we don't make this required, but it's optional.
But yeah, if there's multiple implementations that are literally indistinguishable from each other, then yeah, it seems like the kind of thing where you have an extension and say, oh, there's this extension that vendors have tacitly agreed on, and multiple vendors have implemented it, and so we're gonna have a capability bit that lets you say you want it and lets you find out if you've got it, et cetera. That's the whole optional extension thing and that would have to be from top to bottom, all the way from the storage class down through the sidecars and the RPC to basically have some negotiation to say, is this feature available or not? But yeah, I thought that what we were focused on was like a portable mechanism for doing secret rotation when using S3.
Or yeah.
I still haven't heard of that. Like there's it sounds like there's very good mechanisms if you want to tie yourself to a specific implementation.
Let me put it this way. So if we provided a generic mechanism for drivers to return some details back, a bunch of files, bunch of environment variables, actually that's it, and whatever is there gets put into the pod, workload pod. We don't know what these files are. We don't know what these, completely opaque to Cozy. We don't know what these environment variables are. We just set them as provided by the driver.
But if it's opaque, we're not adding any value, right? The whole point of Cozy is we have a clearly defined downward API that you can consume. If the definition of the downward API is you get a bunch of opaque text, that's not useful to anybody, because what are they going to look for?
So okay, I need to make the distinction here. So the parts that are opaque are the actual values. Say for instance, we don't know if the environment variable returned by the driver is relative URI or full URI or something else. All we know is it returned a set of environment variables that we're going to put into the workload. Now, in terms of what we put in the API itself for the workload, the bucket.yaml, that doesn't change. The bucket.yaml stays as is. It's things like these environment variables and credentials files that'll change.
But I don't see what value they provide, because like if I can't depend on values being there, then I can't write a portable workload that consumes any of them. I'm forced to ignore them for portability's sake. Like,
I see what you mean.
it's
Can it not be a contract between the driver and the workload? Rather than,
well, yeah, that's what the downward API is. It's if we tell you it's S3, if you ask for S3, the contract says you will definitely get all of the following values, and you can depend on that. And then anything above and beyond that is useless, because you can't depend on it unless you have some sort of explicit negotiation that says, like, here's the value that tells you whether you're going to get the extra values or not. And if it says yes, then the extra values are here. And if it says no, the extra values are not there. So then you at least know as a user, like, okay, I go read this variable, I see if the extra values are set or not. And if they are, then I know where to go look for them. And you can have some sort of a capability negotiation. But if it's just like, yeah, you might get some stuff or you might not get some stuff, then anyone who's trying to write an application is going to say, well, I might not get some stuff, so I'm not going to depend on it.
Fair enough. So as of right now, what we have is access keys and secret keys. That's dependable, works across. Well, it's reasonable to expect every provider to have that.
Yeah, because you can't not have them and still be calling yourself S3.
True. And with
but if we have a third parameter, it's not passed inside the container.
Can you repeat that?
I don't understand that. So today, if from the driver, so today for the driver I wrote, I only return access key secret key, right? But if I add a third parameter,
yeah,
it won't be written in the volume.
So, someone is typing, and if you can mute yourself, that would be good.
Yeah.
Go ahead.
So today we return an access key, a socket key pair, right? If we return a triplet, what does it change? Because as far as I know, it's written in the, we are using Amazon-like protocol, so it's written as a dot
What is the
AWS
third? What is the
credential.
third value?
The third value is the token.
So as long as we document what it is, and we say that it cannot be there, like, then people can optionally leverage it when it's there and not when it's not. But it can't be opaque. That's my whole point. Is whatever it is, we have to write in the doc that, like, these are all of this. This is what this value may contain, and these are the possible set of values you might get.
Because applications, they know how to parse, and the Amazon SDKs, they know how to recognize when there is, when you have only 2 keys or you have 3 keys, basically. They know, right? So it doesn't change. Well, I don't see what it's changing.
So, like,
from Amazon compatible application.
go ahead.
The question is, like, would you ever not get the secret key and access key? Like, if somebody just intentionally ignored that third value, would they ever break?
Oh yeah, it will probably break.
That's what I'm saying. Like, it's not portable unless everyone meets the contract.
So we have something in the storage class where we have those secret keys that they are inside the storage class. Can we do something similar for this?
In storage class,
I think if you need to check the external provisioner, it's actually, it's not really, it's not in the API itself. It's basically, it's in the external provisioner.
Those secrets are meant for use by the driver, between the driver and the storage controller. They're never exposed to a user.
Right. I know what you mean. It's in the CSI docs.
Right. Yeah. So this is from the class.
Yeah. It has a signature, right? It looks like something dash secret dash name, and
yeah,
it has a key. It has like a preserved key basically. So it's not know how to parse it. So I was just
the purpose of those is so that CSI drivers can be handed secrets down from above that they can use to authenticate to some storage controller. So those are secrets coming from the top down. We're talking here about secrets coming from the bottom up, because the whole thing is we need to provide a secret to the pod if it's going to do S3.
Right.
And yeah, the thing I wanted to emphasize is, like, we can't have a situation where, like, you either get, you know, the access key and secret or something else, and that force workloads to deal with both situations. Like, if you want to provide an access key and a secret, then we have to say they will always be there, and anything else that is provided is purely optional. You know, if you can use it and do something better, but if you can safely ignore it and you still function, you know, as one would expect.
Or maybe we make it a choice. If you ask for access key, secret key, you get access key, secret key. If you ask for service account, we give you service account based credentials.
But that begins to sound like a different protocol to me. Like, you know, what's one protocol, which is S3 with access key and secret key, which, you know, if that's what you want to do, that's what you'll get. And there's another protocol where you're not given those things.
It's more like a configuration of a particular protocol.
But maybe, I mean, you could go either way. But yeah, it's like, it's a decision you have to make up front, where if my particular workload only knows how to consume access key, secret key, then I need to know what I can ask for that will guarantee that I will get that. And then somebody else who wants to do something better can ask for something else and get the better thing. Or an error. Like there's always the possibility that the particular environment you're running in just doesn't support what you want. And we want to minimize when that occurs, but if it's inevitable, then it is inevitable, and you just return an error, or you fail the request. Like in the case of provisioning a bucket, I guess you would create a BR and it would just never bind, and you'd see a bunch of events on your BR saying, we can't do what you want.
Yeah.
For just for info, for all Amazon compatible applications, they know how to transparently parse the config file, right?
Yeah, but that's still Amazon centric, right?
No, but the point is, so the point is different. So let's say we use Cozy as it is defined today, and for instance, the driver generates temporary tokens and returns the triplet, so access key, secret key token. Written inside the pod, the application knows how to consume the triplet, and that's fine, right? And it's a special. Let's say it's a special vendor driver setting.
Yeah.
Now, what happens if the token expires? What are we supposed to do today? Are we supposed to edit to generate a new bucket access request, edit the pod and change the bucket access request with a new one
this is where I wanted the discussion to go is, yeah, like how could we, you know, in the situation where we wanted to be able to have temporary access keys and secret keys that could expire, how can the driver notify the sidecar that it will expire, and how does the sidecar get the new values at the appropriate time and push them into the workloads?
But do we need to do that in the first place? Can we just say, okay, it's impossible, and the only way?
I don't know if it's impossible. I don't know, but like that's what I think the better approach would be, is just to say,
for instance, generating a new bucket access request. So creating a new bucket access request, for instance, editing.
You can't do that, because if you have an existing pod, it's pointing at an existing BAR. And the whole point is you don't want to restart the pod. You want the pod to just keep running.
Well, maybe that's the requirement that's making it hard for us.
Yeah.
Maybe we have to restart, right?
I mean, if the answer is you just can't do it, then we say, okay, we can't do key rotation within this particular framework of you know, Cozy's giving you an access key and a secret, and just say that's it. And you know, we get key rotation through these other protocols or with these other options and other ways of doing things.
We could have something like so I mean, I don't know if this complicates it, but we could have the concept of key rotation request. What that would do is it would go provision the new keys and then do a rolling upgrade of the pods that are using it.
That would be not bad.
But then you have to out of band sync some cron job or whatever which issues key rotation requests, and make sure that it happens within the lifetime of whichever keys that have been provisioned before, and those two need to be aligned.
Right, key rotation request would be more, you know, it'll be, you know, the cron job would not even, the user won't even see it. They would just say refresh period or something, and we'd automate, our controller would start the cron job and all that. Yeah.
But the user wants to be in control of if his pods are going to get bounced. Nobody's going to be happy if we come along and bounce their pods for them.
Oh, so like immediate rather than, okay, I see what you mean.
Like,
so you're saying it's better if you let them do the cron job versus make the request and it's always immediate?
Well, I don't know what the options are. Has anyone investigated whether it's possible to simply update the access key and secret for a given BA and have that propagate into kubelet and into the running pod in a way that the workload could just reread the old file and get new values?
That last part is the one that we don't know of. We have no solution for.
But I mean, have we tried, or?
That's exactly what a config map does.
Yeah.
The config, so it's dynamic, right? The config map value can update.
Yep.
So,
yes.
So why can't we?
We can do that. We can do that. We can update. The only thing we don't know is how we're going to get the application to use the new values.
Oh. Yeah, okay, so you're saying we can get the secret, the access key and secret all the way into the pod, but it's up to the workload to notice that its key isn't working anymore and to go reread its credential file.
Right.
Well.
And that, to me, that is up to the application. It is the very same as a config file that you keep in a config map, or some generic secret that you keep in a secret and that you mount as a volume in a pod. Then detecting changes in that config file is something you have to code up in your application and then reread the config file or just exit or whatever you want to do when you detect the situation.
So I like that solution because
wait, what's the solution?
the solution of just periodically mutating the BA to have new values when, and then relying on the pod to notice that the values changed, either with some iNotify events or detecting errors and rereading files on errors or whatever.
I mean, iNotify events will have to be listened on by the workload. But yeah, some of the mechanism is possible.
But I mean, from the workload's perspective, this is its config file, right?
Right.
So if we make it clear that part of the way Cozy works is that we sometimes give you new access keys, and you should use the new ones.
Why can't we just say it's going to be a rolling upgrade? So, and see, the idea is if you're using object storage, it's already stateless.
Well, if you're willing to go to the point of bouncing your pod, you could have just made a whole new BAR and get a whole new BA and bind the new pod to the new BAR, and you could do that all yourself, right? At that point, you don't need Cozy to perform any magic for you.
That would be manual and it'll be too much effort. But I'm saying, if we were to say we'll manipulate the access and secret keys in place in the BA, I'm just saying the way it's put into the pod is we don't expect the application to do anything special. We'll just restart the pod, and when the application rereads, like when it starts up and reads the new config, it's the new values.
Right, but people don't like their pods restarting. That's what I've learned.
I completely agree with you on that.
Or they like to be in control of it. Like some people will be like, yeah, who cares? But if you tell someone that by using this feature, your pod might just restart, they'll say, well, then I'm not using that feature at all, right?
If they were to use something like credential rotation request, that's in their control. Only when they call it, it goes and does this.
But now we're building machinery at the Cozy layer to do all this, and I thought that's what we were trying to avoid. We were trying to say, like, push it down to the storage system or the driver. If they want to do credential rotation at their layer, they can. They don't have to. But if they do, there's a mechanism to get the new credentials to go back up, and then we just get out of the way and say,
So how do we know
when
to get the new? Okay, let's go with your approach for a second. I want to explore this. So
the idea would be at any step where the sidecar is minting a credential through satisfying a BAR. In addition to getting back the credential, you would get back a timestamp that would say, refresh time, refresh by date, and maybe an additional expire date that is at a later time. You just get back an additional timestamp, and then the idea would be the controller would have a queue of BAs that need refreshing at some point in the future, and periodically it would look at its queue, and we could guarantee, like, within 60 minutes of anything, we will go and call this API again.
Something we can't because the controller can go down. Cozy can go down.
Yeah, but it should come up at some point as well, and you can
right.
store
it can go down for a little while.
By that point, we could have already.
The idea would be to make some fairly conservative time guarantee, like within 1 hour of the timestamp that the driver returned, we will get a call to go refresh it. So, like, you need at least a buffer of 1 hour, but and these controllers aren't going to go down for more than 1 hour.
So, well, no, that's where the problem lies. So I'll tell you why I'm concerned about this. When an outage happens, let's say a Cozy controller goes down, but the object storage parts are working fine. Now, and if we have an expiry on the tokens, suddenly object storage will also start failing. It'll lead to a cascading failure faster than we'll know.
But normally the way you do this is you say, like, your key is good for 90 days, and at the 60-day mark, you're going to refresh it.
But that's the choice of the drivers.
Well, I mean, you could pick different dates, but the point is, like, in a regime like that, you're going to refresh your keys every 60 days. And if you're late for whatever reason, you can be up to 30 days late and you still don't get into trouble, right? And so the idea is to give you this pretty big buffer. Like, yeah, we're going to rotate you every 60 days, but if it's 61 days or 65 days, it's not a big deal.
Yeah, that's like best practices. Maybe if we allowed that to be controlled by the user, that's okay. Because see, if it's tied into the driver, and the driver chooses 60 days as the expiry, do it on the 59th day because it's okay, and then an outage happens.
Well, that's not good practice. You want to whenever you have an expiration, you probably want to refresh it at about
Right.
the 2/3 point.
Right. That's what I mean. Like, it's a best practice what you're talking about. We can't expect everyone to follow the best practice, but we can put in fail safes. In the sense, we can make it, so it's better to put the responsibility on the user than on the driver.
You can put it in the bucket access clause.
Sorry?
Then you put the TTL of a key pair and when it should be renewed in the bucket access clause.
Yeah, like expiry duration or something like that, something that says how long it'll be alive or how long it'll be valid, and then a refresh duration, refresh period.
I don't know. I'm more comfortable with that kind of scheme where, yeah, the sidecar just calls the driver and the driver returns back, call me again by this time, and we have to have some buffer for the controller downtime, but you do a best effort to call back before or shortly after the time expires, and as long as you have enough of a buffer between your refresh time and your expire time, you can withstand pretty large outages, and then you just go with it.
Okay, that would work. And what's the mechanism we're saying? Do we leave it up to the driver, or are we going to enforce it through, or expect it to be enforced by the driver, but provided by us through the bucket access class?
Well, we don't know that every implementation can expire keys, so we have to allow for the situation where the driver doesn't expire the key ever, right?
I see what you mean.
So you might say, give me a key that's good for at least 60 days, and the driver returns back, here's a key that's good forever. And you can say, okay, great.
Right? That's fine.
Yeah.
That's fine.
And then you just never call back to refresh that particular token. And if the driver does say, oh yeah, this one's going to expire in 60 days, and you're like, okay, you make a note, this is going to expire, so I need to call back after 60 days to get new value and a new expiration date. So and then it's up to the driver whether it wants to expire it or whether it wants to give you a longer.
So consider this scenario: if it gives you back a key that's valid forever, but then it sets the expiry day to 90 days and then says refresh it on the 60th day, we'll go refresh it. We'll go ask the driver to give us a new token, and that implicitly tells the driver to delete the old token. So even though it was valid for 60 days, access can still be rotated, credential can still be rotated.
Well, it would be up to the driver to actually manage the eventual expiry. That's the trick here, is that if you want your driver to be stateless, then it becomes very hard to manage actual expiration, because when you do the refresh, you're going to hand over the new key. Cozy's going to forget about the old key at that moment. It's going to say, okay, I have my new key. The old one, it's still valid for another 30 days, but it's not, I'm going to forget about it because it's not my problem. And it becomes the driver's problem then to remember to expire it 30 days later when it originally said it was going to expire it. So
I mean, there's going to be handshake here. So Cozy is going to tell it, hey, here's the principal ID. This is the account ID or username of the credential that you just previously provisioned. Go expire this for me. Oh yeah, you can't expire it right away. I see what you mean. Yes.
Right. You can we can do the refreshing, but the expiring has to be handled below us. And so somebody has to be doing the state management and keeping track of when it's time to actually expire it, and that has to be the driver's responsibility. And so that's why I was going to say some drivers might opt not to do that because it's stateful and they want to be stateless. So that's okay. I think that's okay to say we're not going to expire the keys ever. We're just going to keep them until you tell us to delete them.
I see. And how do we do the refresh then? Like, so if you say it's entirely up to the driver to say, call me back in 60 days, then we'll just call them back in 60 days. That's what you're saying.
Yeah, and if the driver said that this key isn't going to expire and you call back anyways and ask for the new key, presumably the driver will just give you the old key again and say, it hasn't changed, here's the key, and the expiration is still infinity, and it'll be idempotent, right? You can call it over and over again. You'll keep getting back the same key and the same expiration date of nil or infinity or whatever you want it to be.
So that would still have this problem, right? Where the pods have to be updated with the new key before the old keys are deleted. How would the driver know that
but if the key isn't changing, there's no updates to do.
No, in case of infinity, yes. But what if you were rotating?
Oh yeah, so if it becomes refresh time and you have an old key, you go call, you get the new key, and the driver gives you a new one, then the sidecar would have to update the BA with the new value immediately, and update the expiration time in the BA to the new date, and then the thing that's running on the node would have to notice that the BA changed and do its job to update the file that the pod is observing. That would all just have to sort of happen through watchers and it'd be event driven, right?
Right. But
and then you're done, right?
No, but when does the driver delete the old key though?
It doesn't, like, because the driver doesn't know about keys, it knows about BAs. I'm sorry, the sidecar knows about BAs, right?
The driver itself. So I'll tell you what I mean.
Yeah. So the driver deletes the key at the expiration time or after the expiration time.
So then
no earlier than the expiration time would be the guarantee, right?
Okay, so if the keys do get leaked, then until the expiration time, it can be used for malicious reasons. That's what you're saying.
Yeah, okay. I mean, that's the point of an expiration time.
I see. And but not at the point of rotation time. So it's valid until the point of expiration time. I see. And then for those who don't support expiry, it's infinity. We don't even call refresh.
Right.
We can do that. Right?
Yeah, and the key thing to realize with any kind of key rotation scheme is you have overlapping periods of time where two keys are valid, and but Cozy only ever knows about one of them.
Yeah.
Right. Cozy only ever knows about the most recent valid one, and the driver knows about two of them. And then presumably, if someone comes in and tries to delete the BAR, and the sidecar deletes the BA, the driver would have to be smart enough to clean up both of those keys because they're both associated with the same access request. Just one of So if someone explicitly said revoke access by deleting the BAR, you'd want to revoke all of the access associated with that BA.
There's another problem.
The driver or the storage system, because you don't want to push that state into the driver. The driver or the storage system, the driver doesn't necessarily need to know about the fact that there are multiple.
Right. I mean, it becomes
valid keys.
It becomes an implementation detail, but like the driver would be expected to know that if it had two keys spawned from the same BA, that when that BA was deleted, both of them better go away.
Yeah.
And that would just be an internal state they would have to deal with.
Yeah. The driver itself necessarily wouldn't hold that state. It'll be in the API, in the storage system. Right? That's what you're saying, right, Vanny?
It could be done that way, or the driver could have its own place to store state and manage this all at the driver level if the underlying storage system couldn't do it.
So I personally don't like that, but yeah, if it really wants to, it's up to it. It can do whatever.
I mean, it's an implementation detail. Yeah. That's my point. It's a bad design, but it's possible.
Sure. Yeah, we don't really do that anyway. So here's another problem I see. Let's say the driver gives you a new key, and then we try to update the BA with it. So the sidecar tries to update the BA with it, and updates to the BA fails for whatever reason. Let's say API server is down at that point or whatever. Okay, so it needs to retry.
Yeah, because you'll fail to update the timestamp too, right? You would make the update to the access key and secret key and refresh timestamp all at once, and if an update to any of them fails, an update to all of them would fail, and then next time you restart the sidecar, you would see that it still is due to be updated, and you would try again.
So at that point, is the API expected to be idempotent? The API.
Yeah. Like I was saying, you can keep calling like the refresh token or the get secrets from the, I don't know what we call the RPC. I need to go look at the RPC doc. You can keep calling it over and over again, and you keep getting back the same answer.
Okay, so the same answer is where I'm getting to. So it could be, I mean, like, it's not reasonable to expect the driver to give you back the same set of new credentials, right?
Yeah, it is.
No, because let's say you refresh period is 60 days and expiry is 90 days, and then on the 59th day the sidecar on the 60th day the sidecar calls, gets a set of credentials, let's call them credentials X, and then sidecar goes down before it can update etcd, and then it comes back 15 days later. When it comes back 15 days later, you can't expect it to get credential X again, because credential X has 90 days expiry starting from the 60th day.
So what I'm imagining in my head is, so in order to do any of this, the driver has to have its own clock and notion of time, right? So that it knows when to do its refreshes and its expiries and all those things, or the storage system. Like between the driver and the storage system, there needs to be a clock that's driving events to do
It's
these
just
update events, right?
Can it not be a delta from now?
Well, what I'm imagining is that, like, by specifying the refresh time and the expiry time, what the driver is expressing to the cozy is, this is the moment in time when I'm going to regenerate new keys, and you can come ask for them anytime between refresh time and expiry time, and I'll give you the one that I generated. And if if I regenerate on the 60th day and you don't come ask for it until the 89th day, I'll give you the one I generated on the 69th day, and it'll only have 61 days until it expires, because I generated it 29 days ago. But that's fine, because you can use it. It's good for 61 days, and it expires in 31 days instead of 60 days.
Yeah, but the problem becomes if the amount of time left is less than expiry time minus refresh period. So let's say that instead of 61 days, there's only 10 days left.
On what? The expiry time or refresh time?
Sorry, on the expiry time.
That's fine, as long as I mean, you just get whatever the latest. I'm presuming the existence of some process that is refreshing keys every 60 days, and at any time there's either at any time there's either one or two valid keys.
So okay, I want to go back to that one.
You
okay, go ahead.
You always get the latest one whenever you ask, and whatever its expiry time is. And it's not guaranteed to be valid for 60 days from the moment you ask for it.
Right.
It's guaranteed to be valid for 90 days from the time it was generated.
I see. So you're saying there's an external mechanism. I mean, not external mechanism, some mechanism by which credentials are rotated periodically, and we expect this driver to go get the latest version.
The latest one, and it receives a hint for when it's likely to change again. So it should go ask again at that time. But if it asks late, it's okay, as long as it asks before the expiry date.
Yeah, well, if it asks after the expiry date, it'll be a new set of credentials anyways.
Yeah, and hopefully no one was using it in that interval,
right?
Because they would have gotten an error.
So that external service is where it's very interesting. So we're basically saying there is someone who is rotating credentials, like someone or some piece of software that's rotating credentials. It's like that's being run either as a within the cluster by the driver, or as a part of the driver, or somehow it's enabled in the backend. I would think it's more a part of the driver.
But the point is, it doesn't matter, and to my mind, it's fully general, right? Because then it doesn't matter what you're doing down there. Cozy will call you when you want to be called, and you only have to return one answer, and Cozy will always give that answer to the pods, and then everything else isn't really relevant.
Yeah. So is it fair to say maybe that API need not be idempotent?
Well, I mean, you're saying that you might call it, and every time you call it, you get a new secret.
Yeah.
Like, yeah, I don't see any harm in that, other than that it creates a nightmare for the driver, because every time you return a secret with an expiration date, it has to be valid until that expiration date. And so if someone calls this API every 5 seconds for a month, and you return 80,000 tokens, like, they all have to be valid for the time period that you say.
Yeah.
So at some point, the driver is going to say, wait a minute, I'm just going to start returning them the same token, because I don't want to have to keep track of every token I generate every 5 seconds.
So this is why I'm thinking maybe if we were to, instead of automatically, instead of the driver saying give me new credentials, or a driver even having a concept of expiry, what if we left it to the user entirely, and we said, hey, create a credential rotation request, put it in a cron job if you want, do whatever you like, but whenever your credential rotation request comes in, we go talk to the driver, we get new credentials, put it into the BA, and the rest of the workflow remains as is. So that way what happens is it's not an automated create a million token kind of thing. It's more, you call it when you need it.
What does the user actually do? They create an object?
Yeah.
And then the sidecar observes that object,
Mm-hmm.
and then goes and calls the driver and says, give me the new secret now, and then updates the BA. And then what happens to the object?
So you set a status on the object saying that it's done. It's like a certificate signing request.
And then so you create the object, you wait for the status to transition, and then once it transitions, you delete the object, knowing that the thing you wanted happened. Mm-hmm. And if you forget to do this, then your token just expires, and that's your problem.
Well, yeah, if you have the concept of an expiry at all.
But it seems like this forces users to now become aware that they need to go look at expiration dates on BARs, or we would need to reflect the expiration date up to the BAR so they know when they need to create this object, and then they would need to be watching all those statuses of all their
none
BARs.
Of the cloud providers have expiring tokens, just so you know.
All that's why I'm saying, like, I don't want this to be something we push out in front and say, yeah, everyone's supposed to use this. I'm saying, let's make it totally optional, but have a way that if there is an implementation that does something like this, it just works. Maybe it's still too complicated and we should scrap the whole thing. I'd be okay with that too.
That's also something I'm thinking about.
But it seems like if you want to do anything at all, like, this is sort of maximally flexible, because it basically says whatever the driver wants to do is valid. The sidecar is just going to call it back and get the new credential when the driver asks it to. And that's the end of the story. And the default is the drivers never want to be called back and everything's valid for infinity or until deleted.
Something about the abstraction screams like there is something here. I can't quite put my finger on it. Maybe I'm thinking of it wrong, but this idea of having the workload or having the driver automatically ensure that the secrets that they get back is that important. Then the new rotated credentials are important. That's what's like tough to me.
I think it would just be a matter of like the way one would implement it on top of a system that didn't naturally do this would be every time you get that call, you would go look at the current set of access keys that have been set up for that BA on, or that principal on that bucket. And if there was one that was created within the last X amount of time, just return it. And only if a certain minimum amount of time had passed since anyone had asked about it, you could go ahead and generate a new one. And that would put a cap on how many could get generated, but it would still ensure that you'd have a, if somebody called back very, very late, they would still get a new one that was good for a healthy amount of time.
So okay, let me put it in a different way. So given that AWS doesn't have the concept of, or any of the cloud providers, they don't have the concept of expiring tokens. If we were to put in, there is a likelihood
they do. For instance, in Amazon EKS.
But they're there's special ones. They're the STS ones, right?
Yeah. Not access key and secret key.
Yeah. Okay. All right.
Yeah. Right. So if
so if there's no way on the actual storage backend to like set a timestamp that says this one expires, on May 30th, May 31st, then like that metadata has to get stored in another place, and there has to be another something watching a clock. And then when May 31st comes, it's going to have to go talk to the back end and delete that token because it's time. And so that's state that has to live somewhere.
Yeah, I guess the driver can put that in a Kubernetes CRD if it wants. I mean, we're saying the driver need not know about Kubernetes, but if they really said this is only for Kubernetes, we'll do that. It's fine. Like, they can do that, I guess.
The driver could put it in another bucket, like a special bucket.
Sure.
And it could store all of its state in a special state bucket.
Yeah.
And then it could run its own background threads that were periodically, polling and doing things. I mean, there's ways of doing it.
But now you're assuming tokens are stateful and need to be kept by the backend, which is not necessarily the case.
And it's probably not a good idea because they can be stolen.
A GWT token is, from a service point of view, fully stateless. It's self-describing. You do need a secret in order to be able to understand what is to validate that token, but you don't need to store the token anywhere whatsoever.
Yeah, that's what I'm getting to. Maybe we should.
It's an HMAC.
Right. JWT is pretty great that way. Yeah, you know, it signs the payload, and then nobody can go and change the payload because it's signed with the private key that only you have.
Indeed, and the expiration time, etc., is stored in the token.
Yeah, it's stored in the token itself. Yes, and nothing in the token can be changed. But the token itself can be plain text, like in the sense
but that's so that's good for things that use that protocol, but like S3 is not one of those things.
S3 is not one
like,
of them. Yep.
S3 requires somebody stores this access key in secret, at least where the workload can find it and where the backend can get it, and it has to at least pass through the driver. You're right that the driver probably shouldn't be storing these things, but you don't need to literally store the secret. You could just store the access key and the time associated with that access key.
Right. That's fair enough. That's all should. Yeah, if it just stores the access key and the time associated with the expiry, and when Cozy asks for a new key, it should give the old access key.
As long as it has a way of pulling the secret back out associated with that access key.
No, it doesn't need the secret, right? Because Cozy goes and asks for refresh this token for me, and driver comes back and says, this is your new access key, this is your new secret key. And the next time Cozy asks for a refresh, it'll give the new access key. So it's like it's saying, this was the previous one you gave me.
Including the secret?
No, not including secret, just the access key, just the username.
Right. But this API that you would call would be expected to return the access key and the secret. Like you'd be asking,
right?
But would be saying, give me the values, and you have to return something. You can't just say, here's the access key and no secret, because what if Cozy forgot the secret and needs it again?
So what I'm saying is, when refresh time happens, Cozy would. So in order to make sure that the backend can be idempotent, what we're saying is, we'll give you the previous access key you gave us. Use this as a reference to make sure that the next one you give me, is based off of this. In the sense, let's say there's a consistent hashing or something they do, so that if the previous access key is like if you give the same access key back to me, I'll give you the same new key.
But you have to give the secret too.
Why if it's going to create new access key?
This is the credential minting function, right? The sidecar says, I need a credential so I can populate my BA object, and the driver returns both the access key and the secret, and then
I'm saying both of them
later
change each time. If both of them change each time, you just need a reference to the old one. You don't need the whole thing, right?
Well, then you need a separate. Then the function signature needs to look different. You need to have a return code that says nothing changed, and I'm not telling you what the secret is, right? Like if the return value typically says, here's the access key and here's the secret and here's the expiration date, then when it didn't change, you would need a special return code that said nothing changed and I'm not giving you any data.
Yeah.
And so hopefully then it becomes the responsibility of the sidecar to
just not do anything, just not change what's already there.
To remember the value, and if it ever wanted a new value, it would have to pass in an empty string for the last access key.
Excuse me, time check.
Yeah, we're out of time. Oh, we're actually 2 minutes extra. So let's continue the discussion on Monday. I think today was good, especially. I think first time we made some progress on. Tell me.
But do you really want to be spending this much time on key rotation? I feel like we're pretty deep down a rat hole.
I don't, to be honest. I don't know.
Look, you should. When are you going to schedule this API review meeting again?
So Tim is busy this week. We've reached out to him. Okay. I'm going to send another email today. Let's see what he says. He said he could meet us last Friday, but then when we tried to set up a time, he was busy. So maybe this week, maybe Friday this week, or maybe sometime next week. Do we know when the code freezes or the freeze for this is?
This is 1.22. I don't think that's out yet.
Yeah, the schedule for 1.22 hasn't been announced, but
okay.
It'll be announced.
This is probably a 4 months release. I think there is some change on the release cycle.
Okay.
Maybe.
Xing, do you know where that discussion is going on about?
There is a cap. There was some email saying they want to get that merged, but I don't know that is actually merged yet. It may not be merged yet, but there are some discussion about that.
You're talking about merging the schedule for the next release.
No, not that. I'm talking about the changing the cycle from 3 months to 4 months, and there is a cap about that. I think that one is probably still not merged. It's been there for a very long time. So, but I suspect it's going to be changed for 1.22.
Okay.
But I'm not 100% sure. And then that release schedule is not out yet.
And if they do that, then that means it's 4 months forever. Every release is 4 months.
Yeah, if they change that, then it'll be always three release a year. Yeah.
Okay. Okay. Yeah, I know that's something they were considering. I just didn't know who was arguing for and against and why and all that. But
there's an email earlier this week to ask for comments on that cap, so it's likely not merged yet.
So I liked it when it was 4 releases a year, 3 months each, but maybe
yeah, I think it's 4 releases a little bit too much, especially I think for the user, they're pretty slow in updating. So okay.
All right. So let's continue on Monday. I want to finish, let's make a decision on Monday about how we're going to go with the credential rotation, and reach a conclusion. There are a lot of other things to talk about, so we'll start talking about the next priorities soon.
Okay, cool.
All right. Thank you.
Thanks.
Bye.
Thank you.